GCSE maths, quickly going over composite functions and solving equations involving composite functions in hopefully 3 to 5 minutes. Okay, so this is question 17 from an GCSE exam paper. But it's also applicable for BS and Edexcel GCSE maths, AQA and OCR higher tier only. Functions g and h are such that g of x equals 11 over x minus 5, h of x equals x squared plus 4, where x is strictly bigger than or equal to 0. What value of x must be excluded from any domain of g? Well, that's when the denominator is equal to 0, so it's when 2x minus 5 equals 0. Okay, I'm going to add 5 and then divide by 2. When I do that, we get x is 5 halves or 2.5. The reason for that, guys, is because obviously I can't divide by 0 in maths. Okay, obviously it becomes math error. It's not possible. Okay, I can't do 11 divided by 0 because there's no actual value. Okay, but we say I'm going to be a bit off topic here, but we say that you divide by a really small number, then it tends to infinity. Okay, so the smaller number you divide by, it gets closer and closer to infinity. Okay, that's not actually possible. Divided by 0. Okay. Part B, solve gh of x is equal to 1. So we take h of x and put it into g of x. So wherever we have an x, replace here with 2x squared plus 4. You can have 11 over 2 lots of x squared plus 4. Close the brackets and then subtract 5. Okay. Now this fraction equation is going to be equal to 1. Okay. So remember, I've taken h of x and I've put it into g of x. So wherever I've got an x in g of x, I've replaced that with x squared plus 4. Okay. So this is here called composite functions. Okay, next part, so let's see expand on the bottom, our denominator. So we're going to have 2x squared plus 8 minus 5, so that'll be 2x squared plus 3. Once I collect my like terms, because you have plus 8, and then plus 8 minus 5 is equal to 3. That's equal to 1. I'm now going to times both sides of my equation here by 2x squared plus 3 to get rid of the fraction on the left hand side. So we're going to have 11 equal to 1 lot of 2x plus 3, just 2x squared plus 3. Because 1 times anything makes anything. I'm now going to subtract 3 on both sides. So 11 minus 3 makes 8. So we have 8 is equal to 2x squared. Okay. I'm now going to divide by 2, get rid of that 2 at the front. So divide by 2, we get 8 halves is equal to 4. We have 4 is equal to x squared. Okay, so let's just rewrite here. X squared equals 4. Okay. The last step, guys, is just to obviously do the opposite of squaring here, which will be square rooting. So x is equal to plus or minus square root of 4, okay, which is plus or minus 2. Okay, and that, guys, is solving composite equation for functions. Okay, involves a quadratic. Okay, so remember, guys, whenever you have x squared equals a number, in general, you will always have 2 distinct solutions. Now, of course, obviously check and look at your context. If it's length, time, that I'm looking at, obviously I can't have a negative value, but in general, okay, a quadratic equation in GCSE maths will have 2 distinct roots unless otherwise told. Okay, so whenever you have x squared equals a number, okay, as long as that number is bigger than 0, then x is equal to plus or minus the square root of that number. okay? Of course, disregard the negative, yeah, based on the context, but obviously read the question carefully. So yeah, obviously look at the contextualized, yeah, context. Yeah, if it's time, length, height, area, volume, okay, they obviously can't be negative. Whereas obviously, yeah, some things, yeah, like displacement, yeah, velocity, yeah, acceleration, yeah, obviously they can be negative, yeah, as well. But yeah, a quadratic, yeah, equation will usually have two distinct solutions, yeah, okay, based on what you are given, okay, unless taught otherwise in the question, okay. But you can also have, yeah, a repeated root, where you have just one root, or you have, of course, yeah, no roots, okay. Yeah, that's it for question number 17, okay, thank you.